Okay, today we're going to continue graphing quadratic inequalities and as well as graph systems of quadratic inequalities. Let's begin by reviewing the 5 steps that we know to graph quadratic inequalities. The first step is here to choose whether the graph is dashed or solid. I know I used dashed in class. Instead of dashed, I wrote dotted on this note sheet, or dotted on the note sheet. You need to check whether this is dotted, dashed, or solid, and it's dashed because there's no equality underneath the inequality sign, so we'll say it's dashed, or in other words, dotted. All right, and so the second step is to just go ahead and rewrite this as an equation. So I'm going to do that here, up here in blue. So I'm going to rewrite that. If I get my pen to work here, there we go. Let's try that again. It's going to be y equals 3 times x minus 4 squared minus 8. What form is this in? You should recognize this as vertex form. The nice part about vertex form is it gives us our vertex. What would be the coordinates of that vertex? Okay, I'm moving on to step 3 right now. Step 3 is graphing. So this part I'm going to use here to graph is the vertex, and it's 4, comma, negative 8. And I got that from the h and k value present in the equation. What's the axis of symmetry? Well, of course, it has to be the x value of the vertex, so 4. We'll go ahead and just start by graphing the axis of symmetry as well as that vertex, 4, negative 8. Now you can make a short little table for this now. So I'm going to make 3 columns. Use the traditional values we've used all the time, graphing parent functions, those 5 x values. We square them with the parent function y equals x squared. Then I multiply by a. What is our a value in this problem? It's 3, so I have 12, 3, 0, 3, 12. Cross out the middle column and graph these ordered pairs from the vertex. So we'll start by doing negative 2 up 12. So I go 2 to the left, up 12. 2, 4, 6, 8, 10, 12 units up. 1 over 3 units up. And then reflect those points over the axis of symmetry. And now I have something that's kind of like this. Now before I graph it, remember to check, am I dashed or solid? Okay, it's dashed. So I'm going to connect these dots like they are solid, but what I'm going to do after I'm done graphing is I'm just going to erase parts of the parabola to make it look like it's dashed. Now, please forgive me for my crooked lines here, the wavy lines. I'm using a tablet to record this video, so they're not going to be super straight. I'm going to try my best though. All right, the fourth step is down here, the test points. I have to test a point to see whether it's inside or outside the parabola. So I'm going to test the point 0, 0. You don't always have to do that, but I'm going to just do that to make it easy. And I'll plug it into the inequality up at the start. 0, y is greater than 3 times 0 minus 4 squared minus 8. So we're going to go down, we're going to check this out. 0 is greater than, what's 0 minus 4? Well, that's going to be negative 4 squared minus 8. 0 is greater than 3 times negative 4 squared is 16. Minus 8, 3 times 16, 48. Minus 8. So 0 bigger than 40. Well, that's certainly not true. So then I'm not going to shade where that test point was. And you see where the test point is? The test point is right at the origin, and I can't, normally if it did work, I would be shading out here. If it did work, I'd be shading on the outside of the parabola, or underneath the parabola technically. But it didn't work, so I'm going to shade inside that parabola. So I'm going to use the red highlighter here. I'm just going to shade in here. One thing to note, why do we care whether this is solid or dashed? Well, if it's dashed, any point that's on the outside, so for instance, this point right here at 5, negative 5, that is not a solution because it's on the dashed part of the parabola and the dashed part is not included. However, if this is a solid parabola, then that point would be part of it. Now, I've kind of brushed over the fact that step 5 was shading, but those are the 5 steps. Tell me whether it's dashed or solid. Write it as an equation instead of an inequality. Then graph it. Then test a point, and then shade. Let's do another one that's in a slightly different form. All right, this is in the factored or intercept form. First, is it dotted or solid? And I'm sorry, again, I'm going to say dashed, dotted interchangeably here. While we look underneath the inequality sign, it certainly looks like it's solid this time. It's the first time we've had a solid parabola, so I'm going to circle the solid option. That was step 1. Look at the inequality. Tell me whether it's dashed or solid. This one is solid because there's the equality underneath it. Step 2 is going to write this inequality as an equation. Y equals 2 times x plus 3, x minus 1. Step 3 is to graph this. Now, it's because it is in intercept form, the first thing I want to do is find what the x-intercepts are. So I'm going to set those two factors equal to 0 and solve for x. So I get x is either -3 or x is going to be +1. And those are going to be my intercepts, +1, -3. And I should note that its ordered pair is -3, 0, +1, 0. And to find the axis of symmetry, well, of course, you find the average, or the middle of those two. So you could add -3 plus 1 and get -2, and then divide that by 2 to get -1, or just count to the middle between the two x-intercepts. So x equals -1. To find the vertex, of course, you know to plug that -1 into the equation for x. So I have y equals 2 times -1 plus 3, -1 minus 1. So then I have y equals 2 times +2 times a -2. So then I get -8 is my outcome there. So my vertex is at -1, -8. I don't know why that's there. I'm going to move that out of my way quick. Take that little pen stroke away also. I don't know why it's not going away, but I'll just erase it. So 1, -8 is going to be my vertex. I'll go ahead and just plot that on my graph. And you can just use a table. My a value is 2, so I'm going to go over 1 up 2, over 1 up 2, and over 2 up 8, and so on. So I'm going to just connect those really quickly, and notice it's solid this time. Again, I apologize that my lines are a little bit wobbly. Trying my best. What's step 4? I've determined whether it's dashed or solid, determined whether it's wrote it as equation, found the graph. Now I need to test the points. This is step 4. 0, 0. I'm going to just test a point. Now that 0, 0, notice is inside the parabola. So if it works, I'm going to color in here. If it doesn't, I'm going to color outside or below. So I'm going to test it by plugging into the original inequality. 2 times 0 plus 3, 0 minus 1. So 0 is less than or equal to 2 times 3 times -1. 0 is less than -6. That's not true. Now look where the test point was. It was above the parabola or inside. So that means I have to color on the outside of it or below it. So actually, this is what the graph would look like of this inequality. So it's going pretty slow during that part. I have about half the video done now, so I have to go a little bit quicker. The new part of this video is basically doing the same 5 steps over and over again, but now I'm going to do 2 graphs at the same time. And the interesting thing is the solution to the system is where the 2 shaded areas overlap. First things first. Let's graph the first one. And the first graph I'm going to make, let's do pink. Now, so I'm going to do the pink side over here on the left, and then I'm going to make the other one green on that side. First things first, dotted or solid for the pink parabola. Well, there's an equality underneath, so it has to be solid. So step 1 is done. It's solid. All right, I'm not going to write it as equation, but that's what step 2 would be. The axis of symmetry would be between the 2 x-intercepts of this graph. And so the x-intercepts of this graph are going to be -4, 0, and +2, 0. I'll go ahead and graph those. And I got those 2 x-intercepts by doing the same method I did before. Set those factors equal to 0. Axis of symmetry is going to be in the middle between 2 and -4. That's going to be at, I believe, looks like -1. So I'm going to put that axis of symmetry in there for the pink parabola. X equals -1. I have to plug that -1 into the function to get the vertex. Y equals -1 plus 4, -1 minus 2, -1 times 3 times -3. So that makes it +9. So the vertex is going to be -1, +9. Again, I'm doing the math kind of as an afterthought because at this point you should be pretty good at doing this. I don't really have to explain a whole lot about what I'm doing at this moment because it's the same type of graphing that we've been doing for the past 3 or 4 units. Now A is -1, so don't forget to make these last column values negative. So in a graph, here's my parabola. Should go just like that. 1, 2, 3, 4, 5, 6, 7. I'm just getting one more point in there just to make sure that my graph looks as good as it could. I'm going to try my best not to make it wobble too bad. I have to do test points. I'm going to do test point in the pink parabola. I'm going to do 0, 0 again for the pink parabola. Plug it in and see whether it works. -4, -2. I'm just putting 0 in those spots for x. -4 times -2 is +8. That's true. 0 is smaller than 8. We got one that worked. So in this case, I'm going to shade where that test point was, which is underneath. I'm going to just do that. That's where my shading is. Let's graph the other one now in green. Okay, first of all, solid or dashed. This one is going to be dashed. Okay, we know it's dashed because there's no equality underneath the inequality sign. All right, I'm not going to rewrite this equation. That would be step 2 typically. Let's find the axis of symmetry. What form is this in? Well, this is vertex form, so thank goodness it's a pretty easy parabola to graph. I know the vertex is at -3, +9 based on the h and k values. The axis of symmetry is x equals -3. Go ahead and put in that x equals -3. Now you have to be sort of careful because this thing can get kind of messy if you're graphing two parabolas at the same time. But if you're careful and pay attention, and if you have other colors, that's pretty helpful that I've found. Now to graph this, I said the vertex said -3, +9. It's going to open downward. And this has a value of 2, so when I make my table, I'm going to multiply my a values or my y values at the end by that -2, excuse me. So this is going to be -8, -2, 0, -2, -8. Cross those out. These are my ordered pairs now. 2 over 8 down. It makes me go here. 1 over 2 down, and so on. I'm just going to go one more point. 1, 2, 3. And then reflect that over. Probably about right at here. Now this is dashed, so be careful. So I'm gonna have to just draw it dashed as I go because I don't think I could use the eraser and do as good of a job. So there you go. I do a test point for my green parabola. This time I'm gonna do 0, 0 again, but notice that 0, 0 now is above the parabola or outside of it. Let's see if that point works. 0 greater than -2 times 3 squared plus 9. Let's see if it works. -2 times 9 plus 9. So I'm just doing the math again. I know that this is probably not the most exciting part of the video, but it's important to show how I'm getting this. Is 0 greater than -9? It is. So my test point worked. But do you see where my test point is relative to my parabola? Here it is. My mouse is clicking on it now. It's above or outside of the parabola. So that means when I'm coloring in with my highlighter on this video, I'm going to color in outside the parabola. Now the solution to this problem, the answer, is where the green and the purple sort of overlap. And I know it's kind of hard to tell, but you could see I'm going to just color it in really dark blue now. Right in this area where I have both the pink and the green parabolas sort of overlapping, their pink and their green, that is going to be my solution. And if you don't have colors, just darken that area in the most. We'll talk about the better strategies and how to graph this if you don't have color when we're in class tomorrow. In fact, I'm just going to leave the video at that. We're going to do this example in class just to make sure everybody's on the same page. I hope you have a great day.